So welcome to our Dplyr session. So just a bit of introduction. So Dplyr is before Ian comes, I hope Ian is here. Ian Mushiri will be taking us through today's session. Yeah, so so Dplyr is just a package for wrangling data, wrangling and transforming data, where wrangling is trying to put the data into the right format for further analysis, and transformation of data is, maybe adding new rows, new columns, doing some calculations with it. Yeah, so I hope that's what Ian has in store for us. So Ian? Hello, Ian? Okay, so just a minute. As we wait for our today's speaker to come. Yes. So Ian? Okay, as Ian comes, as highlighted in the screen as shared, we'll be requiring RStudio, R software, and internet connectivity for people who will be watching the recorded version of this. Yeah, and and the data, obviously, which you can get from a package. The coronavirus package, or you can follow some steps written in the RPubs website. Yeah, so I don't know how you said it's not for the faint-hearted. Anyway, Ian, I think Ian is here, so yeah, I think the stage is all yours.
Just a moment, I'm still setting up. Yeah, I guess you're all settled in.
Yeah.
Okay.
Okay.
So from the screen I shared, you can see that today's session we are going to discuss Dplyr and some basic verbs that are used with Dplyr. So I don't know how we are going to go about this. I hope you guys already have RStudio, R software. Yeah, those two, the two software which you're going to be using. And yeah, so we can start. And since this will be a recorded session, maybe if you get lost somewhere, you can always get the recording and maybe go through it. And if you want to contact me, yeah, you can always contact me. And yeah, if you have a question, we can sort it through. Yeah, so for this session, we're going to be using COVID-19 data set. Yeah, the data set that contains information about cases regarding COVID-19. Yeah, so because of relevance and all, we said we'll use a data set which is relevant to the situation that we are facing right now as a country. Yeah, so there are two ways of accessing the data set. There is one which was published by Eric, and this was the link to following those steps. But for I opted for the second alternative, which is to install the coronavirus library. Yeah, it's a library which is available for R, and yeah, the steps to install the packages are as illustrated here below. So you'll just type in the command install.packages coronavirus. Yeah, and then you load the package using the second line of code. Yeah, and to ensure that you're all good, you're all set, you can always view to see if you have the installed package. Yeah, using this command. Yeah, and just to illustrate, yeah, so just a moment before we go to illustrating, we'll also be using a package called Dplyr. Yeah, package called Dplyr, and the Dplyr package is found within Tidyverse. So we'll also need, if you don't have the Tidyverse already installed, you'll have to run this command. Yeah, and you'll have Tidyverse installed in your PC. Yeah, and yeah, with a few downloads, yeah, you'll be good to go. So, so let's. I already did that before the session, so I'll just go ahead and load the package. Yeah, and you'll get a message saying that coronavirus was built under R version 3.63. Yeah, or something. Yeah. Although coronavirus wasn't built in R, but the package itself was built in R. Yeah, and you load the library Tidyverse. Yeah, it will buffer for a bit because the package is large, and then yeah, you'll get a message of the like this. Yeah, it will show you the packages which are installed in R. The package Tidyverse. So the Tidyverse has a lot of packages. There are packages called ggplot, tbold, idr, readr, far, and the rest. Yeah. So, and this message over here just shows you some conflict, telling you that there's some functions that are maybe found in two packages in R. So don't really worry about it, even though it says it's conflict. Yeah. So, after you run the two commands, you can always type in the view command, see how the packet looks like. Yeah, and when you run this command, just a moment, my PC is a bit slow. Yeah, you'll get a table that's showing you the date which the case was reported. So, for example, the first column, it's on 22nd. The country, the latitude, the longitude, the type of the case, confirmed, recovered, or deceased. Yeah, and the number of cases. Yeah, in the province. Yeah, so you'll get a table like this. Yeah, this is the data set which you're going to be using today. Yeah, so yeah, after loading the data, yeah, you can start. So just a moment, I think I'm in the wrong file. Yeah, so there are 6 key Dplyr verbs which we are going to be discussing, and the verbs are filter, arrange, select, group by, mutate, and summarize. Yeah, and from basic English, you can almost like have like intuit like what each verb is going to be used for. So filter is used basically to filter maybe certain rows, certain columns in your data set. Arrange is used to rearrange the data set. So for example, there's a certain column, you want to move it to another place, you can always use arrange for that. Select is used to select columns. Group by, the same thing. It is used to group a number of variables in your data set. Mutate is used to add columns. Add columns to the data set which you're using. Yeah, so maybe you want to add some more information on the data set that you have. Yeah, so you'll do that using mutate. And summarize gives you a summary of your data set. Yeah, so these are the six verbs which we are going to be focusing on this evening. Yeah, so let's get right to it. We start with the filter function. The filter functions allows one to pick observations by their values. Yeah, so you'll realize the syntax for the verbs that we have just mentioned above is more or less similar, because you'll have the verb filter, and then the first argument that you'll pass to the verb is usually the data set which you're going to be using. So which is coronavirus data set. Yeah, and the parameters which you're going to pass. So the syntax for every verb is more or less the same. So when it comes to a function like summarize, you'll have summarize, the first argument being the data set, and the second, third arguments being the variables that you're going to be using. Yeah, so for example, as you can see, the data set that we have is very large and contains information about different countries. So the first country, I think they were arranged in alphabetical order, is Afghanistan. Yeah, and as we scroll down, you can see there are countries like Cuba, and basically all the countries in the world, Australia, and the rest. So for this session, maybe we are not interested because we are Kenyans. Maybe you're interested in the cases that are happening in Kenya. So we'll use the filter function to kind of narrow it down. So this line of code here filters the cases that are happening in Kenya, that happened in Kenya. And just to illustrate, I decided to select maybe the cases on 23rd April 2020. Yeah, and when you run this line of code, you'll see that from the large data set that we have, we are able just to get 3 entries. Yeah, showing the confirmed cases on 23rd of April being 17. Yeah, the deaths were 0, and the recovered cases were 15. Yeah, and the country specifically is Kenya. Yeah, so with filter, we are able to filter out other observations and single out observations of Kenya on the 23rd of April. Yeah, and the results which we get are actually stored in a new data frame. Yeah, and we can use this information to do further processing. Yeah, so for fun, maybe when you get, because I'll post these materials in my GitHub account, you could try rerunning the code with other filter parameters just to see how it works. Yeah, so since the results are actually a new data frame, you can store the new data frame, and actually use it separately, instead of, as opposed to using the whole data set. You just have a subset of the larger data set which you're going to be using for the session. So for example, for the results that you obtained above, you can actually assign them a variable name, these results. You can actually assign them a new variable name and create actually a new data frame which you're going to use maybe for some further processing. And when you run this piece of code, you can see, just a moment. You can actually see you get a new data frame that only has 3 values, as compared to the initial one which had hundreds and hundreds of rows. Also, with filter, you can use comparison operators such as larger than, greater than, equal to, not equal to, and logic operators to make the filtering more efficient. So as you can see, in this case, you use the filter verb. We had the data set which we are going to be using. Yeah, we filtered by country, and the dates we actually had 2 dates, the 23rd and the 24th. The sign over here, this sign that I'm highlighting, is actually an OR sign. So the new data frame which we are getting are actually values which were gotten on the 23rd or the 24th. Yeah, so as you can see here, once you run this line of code, you'll get the cases for the 2 days. Yeah, so that's how you can use a comparison operator or a logical operator, because the syntax is more or less the same. Yeah, you can use them to actually narrow down your large data set. Yeah, and we have a subset. We have a shorthand for this problem, which is X percentage in percentage Y. Yeah, so when you see this, what happens is this selects every row where X is one of the values in Y. So what do we mean by this? So for example, in this case, our X is the number of cases. Yeah, and our Y is 17 or 25, meaning, yeah, we want to filter out the cases that happened in Kenya, but we want to know maybe the specific day which the cases were either 17 or 25. Yeah, so when you run this, each and every row of Kenya that has the value cases equals 17 or 25, yeah, will be isolated and actually displayed as an output. Yeah, so when you run this piece of code, yeah, you'll actually get a new data set that tells you on 23rd of April, yeah, and the 4th of May and the 7th of May, the cases were either 17 or 25. Yeah, so that's how you can use this symbol over here, yeah, to actually determine the number of, yeah, using it instead of yeah, typing all this which we typed before. We can just use it as a shorthand, yeah, using the filter function. Yeah, so there also something when you deal with data, yeah, you might get an incomplete data set, which does not really have some values, or some values are missing. Yeah, and when you get such a data set, yeah, the missing values are always represented by an A. Yeah, which means not available. Yeah, so more often than not, you'll get the data set is really huge, so you can't really go inspecting for missing values by your eyes. So that's why we have the is.na function. Yeah, so the is.na function, yeah, it actually checks your data set to see if there's a missing value. And if there's a missing value in the data set that you have, yeah, it returns a true value. Yeah, so to illustrate this, I created like a small data set. Yeah, and the data set I created was, okay, this is how you create data sets in R. Yeah, so I created a data set which had value 1, 23, 25, 22, then a missing value, then 3. Yeah, and once you run this and type in the is.na function, yeah, you get a result like this. Yeah, something like this. Yeah, telling you that the NA value is actually in the 5th position. Yeah, so yeah, you can actually tell that a data set that you've created actually contains an NA value. Yeah, so by default, the filter function does not consider the missing values. So that's why when you run a code saying that you filter the value of X greater than, or equal to 1, the NA value won't appear in the results. Just a moment. Yeah, so from the results that you're getting, the NA value is omitted, meaning that that the filter actually discards the missing value. So if you want to explicitly ask for the missing value, you have to call it in the function. Yeah, as shown here. Yeah, so when you run this line of code, you'll see that the missing value is actually outputted in the results. Yeah, so that's one of the key things you need to know about the filter function. Yeah, so that's basically all when it comes to the filter function. Yeah, so we move to arrange. Yeah, so arrange works similarly to filter, except that it selects rows. Yeah, instead of selecting rows, it changes their order. Yeah, so as you can see from the arrangement of our data set, yeah, it's date, province, country, latitude, longitude, type, and the cases. Yeah, so if you want to rearrange maybe the columns, yeah, you use arrange coronavirus. Yeah, arrange, then the data set which you're using, yeah, then the order that or what you want to arrange by. Yeah, so for example, you can say that you want the latitudes, yeah, and the longitudes to actually be arranged in an ascending order. Yeah, from the least to the maximum. So you pass that as your parameter. Yeah, and when you run this piece of code, you'll see that the latitudes are actually going increasing. Yeah, okay. The columns, if you look at the column latitude, yeah, you will see that, yeah, because if you observed, if you remember from the first the first table which we viewed, yeah, the first country which was here was Afghanistan because it was arranged in an alphabetical order. Yeah, but right now you can see that the first country being displayed is United Kingdom. Yeah, because now you've rearranged the whole data set based on the latitudes and the longitude. Yeah, so the country which has the least latitude appears first. Yeah, and the latitudes go on increasing gradually. Yeah, so that's how arrange works. And if you wanted to have a descending order, have the values arranged in descending order, yeah, you'll have to use the keyword DESC, descend. Yeah, so for example, this one arranges the countries, the data set based on the number of cases from the highest cases, yeah, to the least number of cases. Yeah, and as you can see from the output, as you can see from the output, the cases are arranged from the maximum to the least. The number of cases go on decreasing, or from 36,188, 34, and 26. Yeah, the values are going on decreasing. Yeah, so yeah, that's how you arrange works. Yeah, so we'll move on to select. So with select, it's used to subset actually a large data set that you may be having. So from the data set that you have, you can see that the data set, let me just run it so that you can actually see it. View coronavirus. Yeah, so yeah, as you can see, from the information being displayed at the bottom of my screen. Yeah, from the bottom of my screen, you can see that there are about 87,808 entries. Yeah, which is actually quite a large, quite a large number. Yeah, and for you to actually do some operations on such a large data set, it might actually be quite cumbersome. Yeah, so you can actually decide to subset the whole data set. Yeah, for this case, our data set has only 7 columns, but in some cases you might find that you have so many columns, but you're only interested in maybe some 3-4 columns that actually interest you or are relevant to your operations. Yeah, so that's where select comes in. Yeah, and the syntax is still the same. So it's select, then you pass a data set as your first argument. Yeah, and the number of columns that you want to actually use as the second, third, fourth, arguments. So for this case, I decided, because we won't be using latitudes and longitudes, you can actually select the date, country, and cases alone and just leave out latitude and longitude. Yeah, and when you run this line of code, you'll see that the columns of latitudes and longitudes have been omitted, and you only have the date, country, and the cases. Yeah. So select actually helps subsetting. Yeah, you subset the larger data set that you have and actually have a smaller fraction of the huge data set. Yeah. So another way to do this, instead of actually typing the name of the variable name assigned to each and every column, you can actually use this syntax. Date, semicolon, latitude. What this one does is actually select a range of columns from. So in this line of code, we're actually selecting the date column, the country, cases, we're selecting the date. Just a moment. Yeah, date, country, and the latitude. Yeah, and we're leaving out the longitude, type, and the cases. Yeah, so it's used to select a range. Yeah, and when you run this, and when you run this, you know why my screen is freezing up. Yeah, when you run this, you'll get only 4 columns. Yeah, finally. The date, province, country, and the latitudes, leaving out the other columns. Yeah. So the other thing that I found of interest is actually this system of writing. It selects all columns except from province to latitude. Yeah, so maybe you want to specify a range which won't be selected. Yeah, so you just have a negative sign before the range which you are setting. Yeah, so if you run this line of code, you'll observe that we are leaving out the columns in between province and longitude. Yeah, so we are leaving out province, country, latitude, and longitude, and we're only left with the remaining columns, which are actually date, type, and the cases. Yeah, so those are 2 ways which you can use mutate. You can use select. Sorry. and that's basically it about when it comes to select. So we go to mutate. Yeah, mutate is used to add new columns to our data set. Yeah, and just to illustrate this, although it won't have so much insight to our data set, you can actually calculate the daily average number of confirmed infections in Kenya and actually append the value we get as a column named average. Yeah, so from the data set that we have, we can't actually tell the average of the number of cases reported in Kenya because the data set only contains values for each and every day, but the average is unknown. Yeah, so maybe when you're getting this coronavirus package, because it's updated daily, or I'm not sure if it's daily or on a weekly basis, maybe your values might be different from what I'm having. Yeah, because maybe the data set will have changed, but yeah, the principle is still the same. Yeah, so to get the daily average number of confirmed infections in Kenya, and Makiu, we're looking at the confirmed infections alone. Yeah, so we have to filter out based on the country, which is Kenya, and actually the type, because we want to find an average of the confirmed cases. Yeah, we have to filter them out based on the confirmed cases. So we'll actually create a new data set. And actually name it new data set. I actually named it new data set. Yeah, and the results of the filter will actually be stored in the data set that I've created named new data set. Yeah, so when you run this, when you run this piece of code and display the results, yeah, you'll get a new you'll get a new table that actually has cases from Kenya alone. Yeah, so as you can see, yeah, you'll get cases from Kenya. Yeah, and we want to calculate the average. So we look at how many cases from Kenya do we have, and to do this, we'll have to use the view, so that we can get a better perspective to the data set that we've created. And when you run this line of code, you'll see that there are about 112 entries. Yeah, but the problem is, okay, it's not a problem really, but okay, let me see. Yeah, so yeah, there are 112 entries. So to calculate the average, yeah, we'll use the literal definition of average, which is the sum of the total number of cases divided by the number of occurrence. Yeah, so in this case, we found that there are 112 cases reported in Kenya. 112 entries. Yeah, so for the 112 days since the dataset was created, so to find the average, we sum the number of cases divided by 112. So when you do this and actually use the function mutate to add it as a column to in the data set that we have. Yeah, and as you can see, the result that we actually get a new column at the very end, called average. Yeah, and it actually tells you that they are from the sum of the cases that we have divided by the number of days, Kenya is experiencing an average rate of infection of 6 infections per day. Yeah, so at least you can get some insight from the data set that we have. Yeah, so you can actually try and find the average rate of mortality and recovery using filter and mutate just as an exercise. Yeah. So if you only want to view the new variables that you just created, you can use the function transmute. And this is a syntax. It's the same syntax as we've been saying. It's the dataset name and then the arguments which you're going to be using. Yeah, with that verb. So when you run it, you'll see that the average. Okay, I don't know why I used 336 here. It should be 112. Yeah, and when you run this, you'll see that you'll just get a column displaying the average, which is about 6 cases per day. Yeah, so basically that's it about mutate. So we move on to group by and summarize. The reason as to why I put these two verbs together is because most of the time they are used simultaneously. You can't use one without the other. Yeah. So summarize collapses a data frame into a single row, but this is not useful because you can't really get a summary of a whole data set. You have to specify the columns that you want to get a summary of. So we have to use group by to actually segregate the summary into columns, for instance. Yeah, so to do this, we decided to okay. Yeah, so the syntax is still the same. You have the verb group by, and then you pass the argument of the data set, and then you say, what do you want to group it by? So in this case, we grouped the data set by date, country, type, and cases. So when you run this and view, so after we've grouped it, we summarize. We summarize, and the syntax for summarize is actually shown. So it's summarize, and then the first variable name is the data set, which is actually the data set which we've created in the line above. And the arguments which you are passing. So for our summary, I decided we are going to calculate the mean. And when you run this, you get a new column called cases average. But for this time, it's not useful because there's no average being calculated, because at the end of the day, if there are 10 cases that happened in a day, then the average in that day should be 10 cases. But as you can see, for example, in Mexico, the recovered cases were 598 and the average was 598. But this might not give you so much information when it comes to the data set that you're handling, but at least it introduces a concept of actually how you can use summarize. And the last bit of code displayed here, the na.rm is equals to true. What happens is this line of code actually tells your program, or the RStudio, if you may, if it's going to include the missing values in the calculations of mean. So if you want the missing values to be included, you set it as true. And if you don't want to include the missing values, the NA values, you can just set it as false, and continue with your analysis. I remember once you set the NA values as false, the total number of the total number of cases recorded will actually be lower because the NA values will be omitted. Meaning the mean that you'll get once you set this value as true or false will actually be different. And just to illustrate what happens if you don't use group by, you can just summarize the coronavirus dataset without actually creating a new dataset and actually see what the result will be like. So for the line of code above here, you saw that you get an average of all the cases. Of all the cases that happened. Is highlighted. You can see that the cases average in every country. But once you look at running summarize without using group by, you can see that the result is actually just a column with a value 68.867, which actually doesn't tell you what the average is all about. It doesn't tell you what average are you calculating, where is the 68 coming from, which is not informative, because the whole point of using the tools is so that you can actually get some meaningful insight from the data set that you're using. So group by and summarize is actually one of the tools which is commonly used when you're working with Dplyr. And just to illustrate how you're going to do this, there's an operator called pipe, the pipe operator, the one I'm highlighting. It's used because it helps one not keep on naming new data frames, even though we don't care about it. As you can see, maybe from the preceding examples that you are doing, you can see, for example, in this case, we only wanted to get the mean, but we had to start creating new data sets, so that we can pass the new data set to another argument. So in this case, it might be simple because we just had 2 steps which you had to do for us to get the mean. But in some cases, you'll find that there are a lot of steps that are involved before you get the final result that you want. So you'll have to create new variable names each and every step of the way, which might actually be quite cumbersome and tedious. So to illustrate this, we said, suppose we want to find the average number of cases confirmed, succumbed, and recovered over a period of time in Kenya. How are we going to do this? How are we going to go about this? So from what we've been learning, the most common way of doing this will be creating a new data set and filtering out the country, which is Kenya, the dates which you want to see the average of, so 23rd or 24th or 25th, and maybe 26th. And once you run this, you can actually see the new data set which you've created. And my laptop is slow. So as you can see, we get a new data frame that has the values of the cases in Kenya. In Kenya on the 23rd, 24th, 25th, and 26th. Yeah, and as you can see, we get the confirmed cases, the death cases, and the recovered cases. But remember, we want to find an average of, yeah, say the confirmed cases only. So after we filter out the values of Kenya for the 3 days, we still have to go a further step and actually filtering the confirmed cases alone, so that you can actually work with the confirmed cases. Yeah, so that you can actually get an average of the confirmed cases in Kenya. So this other line of code, we have to create another data set. I named it confirmed cases, and actually filter based on the type, which is confirmed. And once you run this and view the results which you'll get, view the results which is confirmed cases. Once you run this, yeah, you'll see that you'll get a new data frame, but the type will only be limited to confirmed cases. Yeah, so that's why I'm saying you have to filter it a second time, so that you just be left behind with the confirmed cases. Yeah, and now finally we can calculate the average by using summarize. So summarize the confirmed cases, and then we say the column which will be added will be named confirmed average, and the mean. We calculate the mean, and once you run this, you'll see that the average is actually 13. Yeah, but as you can see, it's quite a tedious process because you had to create almost three new data sets and actually name them. Yeah, so maybe during the process you could have gotten lost and maybe you forget what you named one data set. So that's where the pipe operator comes in, because once you use the pipe operator, you just have to pass the result of one step to the next step. So all this, the whole highlighted code is summarized by actually 2 lines while you're using the pipe operator. So what happens is, for the first step, we filtered based on the country and the dates. Yeah, so that's the first section of our code, which is actually highlighted. And the results that we get from filtering, we pass them to the second filter, which filters based on the type of the case. Was it a confirmed case? Was it a death case? Was it a recovery case? Yeah, and once you filter out the confirmed cases, we pass the results to summarize so that you can find the mean. Yeah, and once you run this line of code, yeah, you'll see that you get a mean of 13. Yeah, and you didn't have to really keep on naming the new data sets that you created. Yeah, so the pipe operator, what it did was it passed the results of one step to the next step, to the next step, to the next step. Yeah, and yeah, so when it comes to deployer, most of the time you're going to really interact with the pipe operator. Yeah, so yeah, that's one of the tricks that you can actually use. Yeah, and a shortcut to typing the pipe operator is, for guys using Windows, it's Control Shift M. Yeah, because most of the time you may find that the operator is becoming quite tedious to type. Yeah. So yeah, and one more thing, if you realized, most of my assignments, I actually use 2 equal signs. Yeah, the 2 equal signs are actually the assignment operator. Yeah, and once you use one of the sign. Example, in this case, if I deleted one of the equal sign and ran this piece of code, you'll get an error message. Yeah, but the good thing is the error message is informative because it tells you that you need two equal signs. Yeah, the two equal signs are actually a signs of equality. Yeah, because there is equality and assignment. Yeah, so for assignment, you only use one equal sign. Just to take you back a little bit, for equals, you can use the highlighted symbol, which is less than and a minus sign, or just an equal. Yeah, which is actually, it still serves the same purpose, but it's good to use so that you cannot get confused. Yeah, so tracking the new data set can be quite tedious and cumbersome. Therefore, we use the pipe operator to make life easier for us. Yeah, and I didn't want the session to be so long, so
Ian, a question.
Yeah, so with that, I think.
The equal sign in R.
Yeah.
The assignment, like break is equals to 1, 2, 3. Is there a shortcut instead of writing less than and minus?
Is there a shortcut?
For instead of or we just have to write is like how in could you repeat the pipe shortcut maybe, please?
Oh yeah, just a moment. Yeah, there's the pipe shortcut.
Yeah.
You'll just have to type in. You press Control-Shift-M.
Okay.
Yeah.
Oh, okay.
Any other question?
Maybe anyone else with a question?
Question, comment, or
I've not understood the pipe. The last using the pipe operator. Can you explain it all over again?
Oh, the pipe using the pipe operator. Okay.
Yes.
So yeah. So what happens? In programs, you'll find that there may be some steps that you have to actually implement before you actually get the final result that you want. Yeah. So in this case, for us to get an average of confirmed cases in Kenya from the data set that we have, we actually have to execute the 3 steps for us to get the results. So the first step was to create a new data set that filters the results from Kenya, specifically Kenya, from the whole data set which we had containing the cases in the world. Yeah, and it contains also information about the dates which we are filtering. So the 23rd, 24th, and 25th, and 26th. Yeah, so that was the first step that you had to do. Yeah, and once you executed the first step, we had to store the results from this step to a new variable. Yeah, which I'm calling a new data set. Yeah, so we had to assign a variable name to the result that we got. Yeah, so the variable name which we assigned was new data set. Yeah, so that was the first step which we had to do. Then the second step was actually get the results from the first step and actually implement it in the second step so that we can filter it again based on the type of cases. Yeah, so the cases which we were interested in were the confirmed cases. Yeah, so we had to filter the results from the first step in the second step. So to do this, we had to call new variable which we created, new data set. Yeah, and once we filtered it, we went to the third step, which was to actually calculate the mean. Yeah, in this scenario, I said that the steps which we followed weren't so many. So maybe in some other cases, you may find that you need like 6-7 steps for you to get the final result which you want. And keeping on naming the results of each and every step might be quite tedious and might be confusing when it comes to coding. Yeah, when you're coding. So that's where we use the pipe operator to prevent the keeping on renaming of each and every step which we are following. Yeah, so for this case, the results of the first step are actually passed on to the next step without actually having renaming a new variable for the purposes of storing the results of the first step using the pipe operator. In simpler terms, the pipe operator just passes the results of one step to the next step without really having to use an intermediary in between them. So you just pass the results directly. Yeah, so in this case, the results of the first filter are passed to the second filter. Yeah, and the results of the second filter operation are sent to the summarize, whereby we calculate the mean. So yeah, the pipe operator just passes the results of one step to another step. Yeah.
Thank you.
Oh, you're welcome. Any other question?
Ian, I have one more. So like summarize on its own doesn't do a lot of stuff. It has to be used with group by explicitly.
Not explicitly, but
okay.
it needs what we call helper functions. Yeah, so group by is one of the helper functions, and there are other functions maybe you can use with summarize.
Oh, okay.
Any other question? Oh yeah, so that brings us to the end of the lesson. I mean, and I'll post the materials. Yeah, so if there are no more questions, I think I'll end it at that. Eric, is there anything else you want to add?
No, I just want to say thank you. Truly, like I really mean it. Thank you so much for taking us through like most of the verbs. Like all of them, I think. I'm not so sure, but most of them. Thank you so much. And then you did it in very easy way. So I believe what you just showed us can be replicated in other data sets. But I just wanted to say thank you. And maybe where you can post material so that because it's a recorded session, maybe I think Josh will post it on YouTube, I think. So maybe if where you could I don't know, post the material so that we can refer to it again, maybe.
I'll post it in my GitHub account.
Okay.
I think
so you'll share the link?
At Ian011. Yeah. So I'll share the link to the repo.
Okay, then I think after that we'll put it somewhere. Link to the materials there. Okay.
Yeah.
Okay,
and we did it that way.
Okay, so maybe something quick where some where else can we learn about? I think Dplyr 1.00 is coming out maybe in the next 2 weeks. Maybe before it comes out, where can we get more material on Dplyr? If you may.
Actually, it's in the material that I've prepared.
Okay.
At the end of it, I've inserted some reference books. Maybe if you want to get some more material on Dplyr, you can actually go through a book by Hadley Wickham, R for Data Science. Yeah.
Oh, nice.
And there's a link to a book, our cookbook. Yeah, our cookbook is also a nice book for getting acquainted with Dplyr. Yeah, and some other books which have inserted links. Yeah, in the material. So yeah.
Okay, so thank you so much. I think that's all on my end. Maybe Bethany, do you have something you want to say?
No, I have nothing at the moment. But thank you so much for this session.
Oh, you're welcome.
Okay, so Ian, thank you, and hoping to see you soon.
Okay, be safe, guys.
Okay.
Yeah, and we'll overcome.
Yeah, we'll overcome. See you soon, Ian. Thank you.
Okay, bye-bye.